This is less than 2.7 on dilations. The essential question here is how can you enlarge or reduce a figure in the coordinate plane? So looking at our first example here, we're going to tell whether the blue figure is a dilation of the red figure. If you're looking at A here, the lines connect corresponding vertices meet at one point. In other words, if I was to take this, go through here, and do that with all of these vertices, I would meet at one point. That means that it is a dilation. The lines connecting corresponding vertices meet at a point, so the blue figure is a dilation of the red figure. The figures on B here, they have the same size and shape. The red figure slides to form the blue figure. So the blue figure is not a dilation, it's not bigger or smaller than the red figure, it's just a translation. So our key idea here is the dilation in the coordinate plane. To dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor of k, whatever that may be. So if k is bigger than 1, it's going to be an enlargement. Your figure is going to get bigger. If k is less than 1, you're going to end up getting a smaller figure. So let's look at example 2 here, dilating a figure. We're going to draw the image of the triangle ABC after dilation with a scale factor of 3. So what you're going to do here is we have our vertices written down here, 1, 3, 2, 3, and 2, 1. And now what I'm asked to find here is what happens if I multiply these by 3. So I've just got, put it on the right setting, 3 times 1 and 3 times 3, and then this one would be 3 times 2, and this is 3 times 3, and then C here would be 3 times 2 and 1 times 3. I know it's hard to kind of see in there. My pen doesn't write super small. So that means these new vertices are going to be 3 times 1 is 3, 9. 6, 9, and 6, 3. So if we go ahead and plot those points, we're going to have 3, go over 3, up 9, over 6, up 9, and then over 6, up 3. So when I connect these points here, I am going to end up with a dilated figure of 3 here. Remember, this is A prime, B prime, and C prime. And see how the vertices all come back and the image is an enlargement because the scale factor is greater than 1. So let's look at example 3 here. We're going to draw the image of the rectangle WXYZ after a dilation with a scale factor of 0.5 or 5/10. Identify the type of dilation. So we've got our chart here, and I went ahead and just did this because I knew my pen wasn't going to write that small. We have our points as -4, -6, -4, 8, 4, 8, and 4, -6. Now we're going to multiply each of those times a half. When I do that, I end up with the new coordinates of -2, -3, -2, 4, 2, 4, and 2, -3. So if I go ahead and plot those points, if you notice, I ended up with a reduction, a smaller. That is because the number I'm multiplying by was less than 1. I mean, it's greater than 0, but less than 1. So it was a dilation that actually was a shrinking dilation. So on example 4 here, we're going to be using more than one transformation. The vertices of a trapezoid are -2, -1. Let's see here. I'm going to go ahead and change my colors so that it matches my next screen here. But we have -2, -1. Go to the -2, -1. -1, +1. 0, 1. And 0, -1. So this here is the quadrilateral that I am going to be dilating. Just remember here that -2, -1 is A, this is B, C, and D. So now the first thing that I'm going to do is it asks me to dilate the trapezoids with respect to the origin using a scale factor of 2. So I'm going to go ahead and multiply all of these by 2. So instead of having 0, 2, I'm going to have 0, 4. And so on, so on. So you should have a shape that looks like this now. A, B, C, D, then dilate it with the respects of the origin using the scale factor of 2. So now it's gotten bigger. But now, the next thing it's asking us to do is to translate it 6 units right and 2 up. Some of you were having problems with this, but all you have to do is take the new points, these A, B, C, D primes, and you're just going to count. And you're going to go 1, 2, 3, 4, 5, 6. You're counting how many boxes, and then up 3, and you're going to put that new point. That's all you have to do, and you're going to do that with all 4 points. When you do that, you end up with this new shape right here that's in the green. That's the dilated figure translated 6 units to the right and 2 up. The coordinates of the new image, which they denote as double prime, is 2, 0, 4, 4, 6, 4, and 6, 0. So our fifth example here is we're describing a sequence of transformations. The red figure is similar to the blue figure. Describe the sequence of transformations in which the blue figure in the image of the red figure. So how exactly did I get from one to the next? So from the graph you can see that the blue figure is half the size of the red figure. So we're going to begin with the dilation with respect to the origin using a scale factor of 1/2. After dilating, here, let's go ahead and do that dilation here. If we go ahead and dilate by 1/2, instead of being 4, 2, it would be 2, 1. Instead of 8, 2, I'd have 4, 1. Instead of 4, -4, I'm going to have 2, -2. And instead of 6, -6, I have 3, -3. So right here is my dilated figure. But what do we notice about this? We noticed I messed up, didn't we? Because this one should have gone right there. This point was 4, -4, so it would have been 2, -2. And this was 8, negative 2, so it should have been 4, negative 2. Said the right numbers, just didn't quite follow them correctly. So, our shape looks like this. Which, if we notice, if we were just to flip that up, in other words, if it was a reflection in the x-axis, then we would have the figure that's up here on top. So go ahead and finish your clever notes. Bring them up to me to check and not your clever notes, your notes, and then get started on clever.